So when you're solving a quadratic inequality, you remember that you first have to sort of factor. So you have those two things multiplying together, and then you can figure out the sign of each of those things with a little number sort of sign chart thing, and then figure out where the inequality answer lies. You know, the same exact method, at least in theory, can be used if you don't have necessarily a quadratic, but if you have a rational inequality. So that is a fraction with an inequality. So let me actually show you this by an example. Suppose that I wanted to find all the values for x so that 3x plus 4, all divided by x plus 1, all that value is going to be always less than or equal to 2. So I want to find all the x's that I can plug in here so that this thing is always true. Well, how do you proceed? Well, the first thing I want to always do, just like you would do with a quadratic, is to get everything over and have something on one side and then 0 on the other. So we always want to have things compared to 0, because then we know it's either positive or negative, and then we know whether it's plus or minus plus or plus plus or minus minus and so on. But with a 2 here, that's not good. So the first step always is to bring everything over and produce a 0 on one side. So what I'll do is I'll actually bring this over to the other side and have the 0 on the right. Let me do this here for you. So this would look like 3x plus 4 divided by x plus 1. But now I'm going to subtract a 2 from both sides. So I've got a minus 2, and that's less than or equal to 0. So there's the happy 0 I wanted. That's great. But now I've got all this stuff here. What I'll do actually is get a common denominator, and I'll combine this fraction with this fraction. Okay, so there's going to be still a little bit more algebra we have to do here. I have to get a common bottom. Remember, this 2 is actually 2 over 1, if you want to think of it that way. So I have to multiply top and bottom by something, and in this case it's going to be x plus 1. So to get a common denominator, I'm going to just keep the first guy, 3x plus 4 over x plus 1. But to add or subtract fractions, I need a common bottom. So I'm going to do this, x plus 1, x plus 1. And that's less than or equal to 0. Look at that really fancy 0. I'm just making it very ovally. Look at that. Woo. Okay, great. Okay, so now I have the common bottom, so I can just subtract the tops. So I'm going to subtract the tops now, and what would I get? I'll write this out here now. What I would see is 3x plus 4 minus 2 times x plus 1. That's all on the top. And on the bottom, I have that common bottom, x plus 1. And that's all less than or equal to 0. Okay? So that's where we are right now. I brought the 2 over, got a common denominator, and combined it. Let's try to actually clean up that top there. Now remember what I've got to do. I've got to now distribute. And I've got to distribute not just the 2, but the negative 2. I've got to subtract all this. Don't make classic mistake number 4. Bing!
Spread the negativity.
The subtracting mistake, right? You have to share the negativity. So this whole thing has to be distributed not only to the x, but also to that plus 1. That's a great, great mistake, which you should never make. Okay, so let's see what we have here. I'd have a 3x, and then I subtract 2 x's away. That just leaves me with x. So this would just be x. And then here I see a 4, but then I have a minus 2 times 1, which is a minus 2. So I have 4 minus 2. Well, that's just plus 2. And on the bottom, I have x plus 1. So actually, this cleaned up quite nicely. You have to admit that after you take this thing and clean it up, it came out quite nice. Okay? That happens a lot of times. You ever have something that looks sort of dingy, and then you clean it up, it looks brand new, right? This is great. Exact same thing here. This is a math example. Okay, now what do you do now? Well, now I'm going to use the exact same method that I used for solving the quadratic inequalities. Namely, I'm going to ask when things are 0. Okay, but I have to be a little bit careful here, because I'm going to ask when the numerator is 0, and that's okay. But I'm also going to ask when the denominator is 0, and that's, of course, no man's land. So we have to be really careful with this. So I'm going to take a number line, and I'm going to mark down the regions where, in fact, the top is 0 and regions where the bottom is 0. So the top is 0. Let's see. When is that equal to 0? Well, when x equals negative 2. So I'm going to put in a negative 2 right here. And I'm going to write a big 0 there. And you could even, if you wanted, to put like a dotted line to show that it's going to separate this world into 2 pieces right here. But now I'm also going to put down where the bottom is 0. Now, where is the bottom equal to 0? Well, you can see that happens when x equals negative 1. If x equals negative 1, I have a 0 in the denominator. So I mark that down. But I'm going to put like a u here. I'm not going to put a number because we know the fraction's undefined. We know that a fraction is undefined when the bottom is 0. So I'm going to put a u there, but I'm going to mark that down anyway because, in fact, it may divide the world up even more. So notice what I'm doing. It's the exact same idea we did with the quadratics. I find out where each piece is equal to 0. Now, with the quadratic, they were factors. Now, with fractions, they're on top of each other, so it's division rather than multiplication. But the idea is the same. I'm going to put down where there's 0. However, where the bottom is 0, I put an undefined, because I know this thing is not defined there. And now I just proceed as normal. I want to find out what the sign of this thing is on these different regions. So what do? All I've got to do is pick a point in there and plug in and see what this produces, a positive or a negative. Whatever it produces at that point, it's going to produce the same thing at all the points in this region. Okay? So let's see. Let's pick a point way out here to the right of -1. How about 0? So let me plug in x equals 0 into this thing and see what it produces. If I put a 0 in here and here, I see 2 over 1. Well, I don't care that it's 2. All I care about is its sign. And I see it's positive. So in fact, if it's positive at this point, it's going to be positive everywhere here. So this is all positive land. OK, now I need to pick a point that's between -1 and -2. Well, there aren't that many easy points. There's like no integers in there, for example. So I'll have to pick something like -1.5. That's something between -1 and -2. Sorry about that. So -1.5 is what we'll pick. If you put in -1.5 and add 2, what do you get? Well, 2 minus 1.5 is a half. So it's positive. All I care about is the sign. It's positive. What about when I put in a -1.5 here? If I have -1.5 and I add 1, I'm left with -0.5. So I have a positive on top and a negative on the bottom. When I divide them, that result is negative. So in fact, this land is actually negative land. And what happens here? Well, here I can pick something like, let's say, -10. If I put in -10 here, I'd see -10 plus 2. That's negative. -10 plus 1, that's negative. Do you see how I'm not actually computing the values, but just thinking through the sign? Right? -10 plus 2 is plainly negative. This is plainly negative. Negative divided by a negative, positive again. So in fact, this land is all positive. So now I can look at my chart and answer the question. The question was, when is this thing less than or equal to 0? So where is it negative? Well, it's negative right in this region right here. You see, you can just read it right off the chart. It's negative all in there. But what about the endpoints? I'm allowed to equal 0. So do I include the endpoints or not? What do you think? Well, here at -2, I know this thing equals 0 because the top is 0. So in fact, I want to include that. So I put in my bracket like that. And I should include -1 because that makes it 0 too, right? Wrong. That is wrong. Because if I plug in -1, it makes the bottom 0 and thus makes the whole thing undefined. So this can never be in the solution because I'm not even allowed to plug that in. So I have to put one of these open parentheses just to graze it like that. So there's the solution graphically. If you want to write it out in interval notation, it would be bracket -2, comma, -1, parentheses. And that's the interval notation answer. That means that if you pick any x value in this region and plug it in here, this will be a true inequality. But if you pick anything else out in this part of the world, in fact, this will no longer be true. So it's the exact same thing as when you have products with inequalities. You have to look at where the tops and bottoms are now 0, but carefully mark the denominator part as undefined, and then just make your sign chart, see what you want, report the news. I'll take a look at another one up next. I'll see you there.